Hey everyone, so this is an example of finding area through parametric integration where the graph is given to you and we need to sketch this particular area. Alright, or rather find this particular area. So first of all, you know that the area is below the x-axis between the curve and the x-axis, and hence we'll be using the form of y dx. Okay, just one way to remember is that it's always the opposite variable. But here's the thing, right? You don't know what these values are. Alright, these lower limit and upper limits are, right? But actually there's really no need to, because you know that you're going to integrate parametrically and you're given the limits already, right? Theta's between pi and 2 pi that forms this graph. So you just need to put in the 2 pi and 2 pi, then start substituting in the stuff immediately. Alright, so there's actually no need to find alpha nor beta, although you can find it by putting pi and 2 pi inside to obtain alpha and beta. But there's really no need to here. Alright, so what happens is this. Now, we have an area below the x-axis. Is there a need to put a minus sign here? Answer is no. Why? You're not integrating with respect to theta, no longer integrating with respect to x anymore. As such, you are not supposed to actually add a negative sign even though it's below the x-axis, because it is not quote-unquote below the theta axis. It doesn't exist anyways. Alright, so just keep it to the lower and upper limits. Alright, if you want to play safe, just add a modulus. Alright, it doesn't matter. Okay, so if need be, add a modulus. Otherwise, just carry on integrating from here, which is substitute y in. We have 3 sine theta. Dx becomes d theta, so following our substitution rule, we have to multiply by dx d theta. So dx d theta, from here we know that it's minus 6 sine theta. Wow, I should give myself some, oh wow. Okay, whoops, didn't really think this through. Okay, so that is simple as that. Then now you integrate, simplify the expression. We then have 2 pi minus 18 sine squared theta, and using our basic integration techniques, we know that this is simply using our double angle formula for cosine theta, or rather, sorry, 1 minus cosine 2 theta. Okay, then from here it's basically 9 theta minus sine 2 theta over 2 from pi to 2 pi. And actually it's quite simple, right? This we already know that it's gonna give us 9 pi. Why? 2 pi into theta, then minus pi to theta, so it will become d pi. 2 pi to sine 2 theta is sine 4 pi, which is 0. Again, you put in pi in, sine 2 pi is also 0, so this whole thing is completely 0 for our sine 2 theta. So this is completely 0, and this is just simply 2 pi minus pi. That's how we get 9 pi units square, which is approximately 28.3 units square. Alright, so this is one example of our parametric integration where we have a graph that's below the x-axis, but we need not flip the integral. And once again, I repeat, if you want to play safe, add a modulus sign. There is no harm to it. Okay, so there we have it, the parametric integration for our area.